Alright, for part 2, let's take a look at a couple more examples. So again, we're going to graph this one. Now be careful, we got that negative right there. And what does that negative do to the graph? Well, it depends on a couple things. One, you can factor out the negative because it is a constant, so a constant multiplier rule. So we can bring out the negative. 3 to the left, and we get 1 over x minus 3. And now let's go ahead, just remember your answer is going to be negative. So now let's go ahead and graph it. Our horizontal asymptote is still 0. What's our vertical? 3. And pick a point. Always pick a point. 0, negative 1/3. It's right down here. So here's our graph again. Now, I have a negative, but as I approach from the left, it's going down to a negative infinity. So what does a negative and a negative make? A positive infinity. Very easy to do. So let's take a look at number 4 here. No negatives, we're good. So if I want to sketch this, now what's going to be different here, I'm still going to have the same vertical asymptote. I'm still going to have the same horizontal. My point, though, be very careful, is going to be 0, and if I plug this in, I get 1/9. It's positive. So we know the left side goes up. But what does the right side do? That's when multiplicity becomes a problem. Multiplicity here is 2, which means if it goes up one side, it has to go up the other side. So where is this heading towards? If we write this out, the limit as x approaches 3 from the left of our function. And if we head from the left, it's going up the s, up. So it's positive infinity, and there's our answer. Alright, so what I would like you guys to do is try numbers 5 and number 6. Be careful with number 6. It's kind of tricky there. We'll talk about that tomorrow. But then let's take a look at the rest of these, okay? Alright, so for number 2, this is our special absolute value. The very thing, remember, just remember, our unknown is going to be at x equals 2. So here's 2. Remember, it's either going to be at 1 or at negative 1. That's just a rule. 1 to the right, negative 1 to the left. We talked about how to graph this earlier this year. It's positive if x is positive, negative if x is negative. So as we approach, now we're looking at the left-hand limit. As we approach from the left, we're approaching negative 1. So there's my answer. So let's try number 8. This time, x cannot be negative 3, so that's our little holes there, our jump. Here's negative 3. Same idea. Remember, it's going to be x plus 3 over x plus 3, or negative x plus 3 over x plus 3. And that comes from the absolute value. So it's either 1 or negative 1 again. So 1 or negative 1. There they are. Positive to the right, negative to the left. And as we approach this time from the right side, we're approaching a positive 1. So the answer is just 1 there. Very easy to do. Alright, let's take a look at number 9. Now for number 9, we got the negative, so we're going to take out that negative here. The limit as x approaches 0 from the right of the absolute value of x over x. This time the bottom can't be 0. So 0 is my little hole there, little gap. So here's 0. Again, it's either going to be 1 or negative 1. So if I graph it, 1 to the right, negative 1 to the left. Now, don't forget your negative. Don't forget your negative. And as we approach from the right, what are we approaching? 1. So therefore, the answer is negative 1. The answer, the limit is 1. We're approaching positive 1, but we got that negative, so we have to change our sign. So let's take a look at number 9 here. I'll help you with number 6 in case you missed it. We're still going to be at x equals 3, and it's still going to be 1 or negative 1. Now, you got to be careful. There's no direction. We're looking for the actual limit. So what we have to do is we need to take the limit from the left and the limit from the right. From the left, we're approaching negative 1. From the right, positive 1. They're not equal. Therefore, does the limit exist? No, it does not exist, and that is because the limit as we approach 3 from the left does not equal the limit as we approach 3 from the right of our function. And there's our answer. Let's try number 9. Now number 9 is similar to number 10 is similar to number 9. We got that 2. We can factor it out. We're going to get 2 times the limit as x approaches 1 from the left of absolute value of x minus 1 over x minus 1. So I graph it. My little gap here, x can't be 1, so here's at 1. It's either going to be 1 or negative 1. That's looking negative 1. We have the 2 out here, so we have to include it 2 times. And what are we approaching as we approach from the left? Negative 1. So the answer, negative 1. So very easy to do these. Now take these home, try these. Try these again if you need to, and we'll see you in class tomorrow. Bye.